Welcome everyone. In this video, what we're going to do is we're going to learn how to name ionic compounds containing polyatomic ions. In a previous video, you saw us naming binary ionic compounds that consisted of just two elements, a metal and a non-metal, and you learned that the metal is always written first. It stays the same. And then the non-metal ends in the suffix IDE. These were three examples. Sodium chloride, you see as NaCl, and we obtained this formula by using the crisscross method. Notice these are the charges for sodium and chlorine, and when they get crossed, the ones cancel and you just get NaCl. Magnesium bromide is another example. Magnesium has a +2 charge. Bromine is a -1 charge, and when this gets crisscrossed, that's how you get the MgBr2 formula. And then with calcium oxide, if you recall, calcium is +2, oxygen is -2. When these get crisscrossed, the 2's are going to end up canceling, they reduce, and you end up getting CaO. Now, these are all binary ionic compounds. It's simply a metal with a non-metal. But what we're going to do now is name an ionic compound that has a metal and a polyatomic ion. There's a list that I'm going to show you in a moment. Here's an example of one. The carbonate ion is CO3 with a -2 charge. The nitrate ion is NO3 with a -1 charge. And you would obtain the formula the same way. For instance, if calcium and carbonate are going to get together, okay? Calcium, as you know, is a +2 charge, and carbonate is a -2 charge. And that's why I have that up here. Now, the same rules apply. When you cross, notice that these two numbers are the same. This number's not involved in crisscrossing. That number's already on the bottom. So if you remember from earlier, if the numbers are the same, they're going to reduce. And if they reduce, this becomes 1 to 1, and it simply becomes CaCO3 like you see there. Now look at this other example with magnesium, which is +2, and nitrate, which is a -1 charge. Again, we don't have to write the ones. I'm doing this to make it more visual. When you crisscross these two, the magnesium will get the 1, which I'm going to erase in a moment, and then the 2 goes to the nitrate. Now watch what we got to do here. To show that the nitrate ion gets this 2, what we're going to do is we're going to put the entire polyatomic in a parentheses, and then the 2 is going to be outside the parentheses as a subscript. Again, we don't have to write the ones, so you're going to end up getting Mg, open parentheses, NO3, close parentheses, and a 2. And that would be the formula for magnesium nitrate. Now, here's some common polyatomic ions. You're going to notice most of them, actually almost all of them, are negative. Ammonium is one of the few. Polyatomics with a positive charge. You'll notice it's NH4 with a +1 charge. Now, one thing you'll notice about polyatomics is that most of them either end in the suffix "ite" or "ate." And there's a little something I'm going to mention about this suffix that will help you remember the polyatomics. One of the things that I like to do is I like to group them by charge as a way to help you remember them a little bit better. Now, what exactly is a polyatomic? Well, let's take an example. Sulfate, which is SO4-2. You'll notice that basically a polyatomic ion is a group of atoms. Okay, I'm going to put a little bracket. This is how you would technically do this. And when you look at this, the sulfate ion, okay, which is a polyatomic. So let's put here, it's a polyatomic ion. I'm going to give you a nice little definition. A polyatomic ion, we can think of it as a group of covalently bonded atoms that acts as a unit and has a charge. So these single bonds here are covalent bonds. They're holding the sulfur and the 4 oxygens together. This whole thing will stick together. It will travel as a unit. And the entire thing has a net charge of -2 in this example. Again, some can be positive, some can be negative. Now, here's what I'm going to do to help you remember these polyatomics. If you go here, I'm going to start off by explaining the ite and ate ending. You're going to notice that most polyatomics end in ate. But some of them, if they have a lower, and you're going to see this, a lower number of oxygens, okay, they're going to be given the ite suffix, and some of these have a higher number of oxygens, and they're going to be given the ate suffix. And I'm going to give you a couple of examples so you can see. So let's go over here, and here's a perfect example. You got NO2 and NO3. Now, the NO2 has 2 oxygens, whereas the NO3 has 3 oxygens. So here we have 2 polyatomics. Again, the first one only has 2 oxygens. The third one here, or the bottom one, has 3. So this one's known as nitrite. Notice that the ite ending goes to whoever has the lower number of oxygens, and this one will get the nitrate ending. Again, it has the higher number of oxygens. Let me give you a couple more examples. This one here, which is -2, there's also 2 of them. The top one has only 3 oxygens. That one gets the sulfite ending, and the sulfate would be the one with the higher number of oxygens. Again, we can also apply that to this one over here. This one's a -3 charge. This one is known as phosphite, and this one over here that has 4 oxygens would be phosphate. Now, there is one that I'd like you to know, where there are 4 of them. They're all -1. One has 1 oxygen, the other one has 2, the other one has 3, and the other one has 4. So this ite-ate rule is used for the 2 middle ones over here. And you'll notice that this one will get the chlorite ending, and this one will get the chlorate ending. So we're applying the ite-ate on both of these. However, there are 2 others here. We can consider them as bookends here. And the one on the top, to differentiate it from the one on the bottom, it's still going to be chlorite, but we're going to add an extra prefix. We're going to add the word hypo. Perhaps you remember from biology, hypotonic. Hypo means low solute. Hypo here means it's the lowest number of oxygens. And then this one's still going to end in chlorate, but we're going to add the prefix. Instead of saying hyper, like hypertonic, we're just going to use the per component of the word hyper. Okay, again, hyper means hypertonic would be high amount of solute. So here we're going to add the word per. So this one would be called perchlorate. So this one has 4. The 2 middle ones use the traditional ite-ate endings. Okay, but then you'll see that there are others. If you look over here, we have other polyatomics. I like to group them by -1. Okay, so we have, there's most of them end in ite or ate. Okay, here's a couple of other popular ones. You got C2H3O2 -1. That one is known as acetate, a very popular one. Notice most do end up in ate. Then you have MnO4. This one is known as permanganate. Okay. Then you have, let's see here. There are a couple that coincidentally end in "ide." Okay, normally when something ends in "ide," you think of it as a non-metal, but there are a couple of polyatomics that coincidentally end in "ide." Here's two that are very popular. This one is hydroxide, and this one is cyanide. Those end in "ide," okay, even though they are polyatomics. All right, so these are just some of the popular ones that end in "ide." And then you got some also that have a -2 charge. We have, earlier we mentioned carbonate. Okay, so let's put here carbonate. Then there's these two here that have chromium in it. There's one that's CrO4 -2, and there's another one that's Cr2O7 -2. The top one is called chromate, and the bottom one is dichromate. Well, that's easy to remember because there's two of them instead. Okay, they both have the same charge at -2. And going back to the "ide" ending, there is one here that's O2 with a -2 charge that ends in "ide." It's called peroxide. Again, usually when they end in "ide," you think of them as nonmetals. These happen to be polyatomics. Now, I'm also going to show you, there is this one. If you add an H in front of carbonate, and I notice I put the spelling there is wrong. Let me fix that. So that's carbonate here. If you put an H in front of the carbonate, what the H does is it removes one of the negative charges. It goes from -2 to -1. And this one can be called either hydrogen carbonate. That's one way of naming this one. So you can say hydrogen carbonate. Or the older name is the word bicarbonate. So these are two different names for the same formula. Now let me show you a couple of more here. For the -3 column, we really have, these are the two I want you to focus on. There are others, okay, and this is not the entire list. These are just some of the more common ones. So we learned earlier this is phosphite and this is phosphate, okay? And we also had seen at the -2 column, we saw sulfite and sulfate. So watch what I'm going to do. I'm going to apply that hydrogen thing. If I add a hydrogen in front, and we did that just a second ago with carbonate. So if I add an H in front of the SO3, it goes from -2 to -1. Same thing would happen over here. And we saw this one already just a moment ago. So we know this is sulfite. So this one would be called hydrogen sulfite, and you can also call it bisulfite. So that's an alternative name for that one. We know this is sulfate, so the same thing happens over here. This one is either hydrogen sulfate, or we can say bisulfate, just like that. Okay, and then we already saw this one down here. That's carbonate and hydrogen carbonate. Now, there is one that I would like to show you with phosphate here. If you put an H in front of the phosphate, the -3 goes to -2, and this one is known as hydrogen phosphate. Okay, and it only goes by this name. And then if I add a second, and look at this, this is an interesting one. If you add a second hydrogen, it goes from being -4 to -1, and this one is known as dihydrogen phosphate. Okay? So this is a nice extensive list of the polyatomics. Now, why don't we practice naming with polyatomics? So, let's imagine we have something like... first, I'll give you a formula and we'll name it, and then we'll go backwards. So let's say we had something like this. Okay? this one is going to be called sodium. And here's the thing with the polyatomics. When you name a polyatomic, the name stays the same. You don't change it. You don't change it to "ide" like you would do with nonmetals. It stays the same. This is the polyatomic acetate. So this is simply sodium acetate, just like that. Okay? Let's try another one. Here we got Mg3PO4 2. So given this formula, how would we name this? Well, this is magnesium, and magnesium is with phosphate. So that would be magnesium phosphate. Okay, let's do one more. Let's say we had aluminum here. Let's put here, we'll do something like this. This one is aluminum. And then that CN is cyanide. That one just happens to end in IDE. So here's a couple of examples when you're given a formula and you're asked to name it. Now what we're going to do is let's go backwards. Let's get a name in here. Okay, so let's go with, let's say I had calcium, and let's put it with, let's say chromate. So here's what you do. First, the symbol for calcium is Ca, and here's where you got to know these polyatomics. This guy is Cr O4 with a -2 charge. Now, if you recall, calcium's always +2, so notice that when the charges are the same, they're going to cancel. Do not do anything with this 4. That 4 belongs to oxygen. So when you crisscross these, you're simply going to get CaCrO4 as an answer. Okay, let's try another. Let's say we had potassium with sulfate. So potassium is the letter K. Sulfate is SO4 -2. From the periodic table, potassium is in group 1. So look what happens when you crisscross this. The K gets the 2. Remember to drop the sign. The SO4 will get this 1. Now, since you don't have to write this 1, there is no need to write this parenthesis. So watch what I'm going to do. Since I don't have to put a 1, there's no need for a parenthesis. So what this formula tells you is that you need 2 potassiums for every 1 sulfate. That's the ratio. It's a 2-to-1 ratio. Let's try another. Let's try, let's say we had magnesium with the polyatomic chlorate. Okay, well, magnesium's Mg, chlorate is Cl O3 with a -1 charge. Magnesium, if you recall, has a +2 charge. Now, pay attention to this. When we crisscross this, remember that's a 1 here. The Mg gets the 1, which we don't need to write it, so I'm going to go ahead and erase it. But the chlorate will get this 2, and to show that the entire chlorate gets the 2, you must put it in parentheses, and the 2 goes out here. This means that there is, for every 1 magnesium, there are 2 chlorates. That would be the ratio. Okay? Now I'm going to show you this. We haven't seen this yet, but ammonium is the only positive polyatomic ion on the list that I gave you. So let's say I wanted to combine ammonium with, let's say, nitrate. Okay? Ammonium is not an element. It's a polyatomic. The formula is NH4 plus 1. Nitrate is NO3 -1. So if you have a +1 and a -1, the ones are basically, they're going to cancel. And you just group these two together. And here you have ammonium nitrate. Remember, these numbers do not get touched. I've been circling what you crisscross from the beginning to avoid any confusion. So that's ammonium nitrate. Now pay attention to this next one. Let's say I had aluminum and hydroxide. Aluminum is Al. Hydroxide, even though it ends in "ide," it's a polyatomic. It's a very popular polyatomic. It's OH, -1 charge. Aluminum has a +3 charge. Now, a lot of students do this. They write this as their answer. And that answer is wrong. Okay? This is what you must do. When you crisscross these two, yes, the aluminum gets the 1, which I'll erase. But there are 2 capital letters. That's a polyatomic. That 3 has to go to both of them. So you have to put it in a parentheses and you put the 3 here. You see, with the parentheses, you're saying that the 3 goes to both the O and the H. Had you not put the parentheses, first of all, it's wrong. And you're saying that the 3 only goes to the hydrogen. It needs to go to both. So you've got to remember to put that parentheses. Okay? All right, so this is how you write formulas involving polyatomics. One of the key things is recognizing the polyatomics, learning them. And one of the best ways to do this is probably grouping them by charge. And I believe what we saw today, the ite and the ate ending does help in distinguishing, something that has like a lower amount of oxygens versus a higher, such as nitrite and nitrate. Okay? Keep in mind the list that I gave you. It doesn't have every single polyatomic, but it has some of the more common ones. There are others, but I think with this list, you have enough there to do well. Okay?